All right, here's the schedule for today. You've probably already seen this a million times. So here's the plan. I have three more, I think it's 3 instructional days, including today. Today's a short day, and that's it. And from that point, then I'll put up the units. I'm putting all this new stuff under Unit 7. I'll put up the Unit 7 test. I'll put up a practice test, and I'll put up a practice final and the final. And you got the rest of the year to just get that stuff done. And I'll update grades twice a week, so you can see when you get to a place where you're happy, you can just stop for the rest of the year, and that'll be your grade. Can't go down from that point. Does that make sense?
Yeah.
Okay? All right, so let's look at the last stuff we have to do. Today we're going to talk about, everybody facing the front, please. Robert, why don't you flip around and look up this way. So we're going to look at radicals. So we're just going to look at some stuff with mostly square roots. And what I want to look at today is just simplifying expressions that have radicals in them. Okay, and this is review. We've talked about this stuff briefly when we were doing our SBAC prep. So this will hopefully sound fairly familiar, but I want to give you a couple additional practice problems on this before you test. The assignment for this, I think, is only 5 or 6 problems total. Okay? So what do we do with something like this, the square root of 20x to the 5th? What you can always do is think about this as a part that's going to be outside of the radical and a part that's stuck inside the radical. And then you just break it down into the number part and the variable part. And the harder of the two is the number part. The variable part is really simple. It's the number part that's a little trickier, but even that's not very bad. You guys have had a lot of practice with things like this. If we want to simplify the square root of 20, we just make a factor tree, right? So help me out with the factor tree here. What are factors of 20?
4 and 5.
And then 2 and 2. Good. Remember, we get a couple of 2s. Couples go out, singles stay in. So we get a couple of 2s and a 5, right? So then if we break the 20 down into a part that's outside and a part that's inside, what does it look like? 2 outside, 5 inside. Okay. What about the variable part? Everybody click them all the way close, please. I don't see everyone's. Here's click close. So what about the variable part? Well, if I have a square root of x to the 5th, now the way to do this is to, first of all, let's convert that into a fractional exponent. Okay, so what is the square root of x to the 5th? What's the number, the invisible number that goes on the radical for a square root? It's a 2. Okay, and what did we say, for example, about if I had something like, let's say, the square root of 7, how could I write that as an exponent instead of a radical? 7 to what power? 1/2. Okay, good. Whatever number is on the radical, even if it's invisible, the number that's on the radical is what goes in the denominator of the fraction with the 1 on top, right? Okay. So then what if I have something like this? What if I have x to the 5th square rooted, right? That means I've got x to the 5th to the 1/2 power, right? Because whatever's inside the radical we take to the 1/2. Thank you. Okay, so then if that's true, if we have x to the 5th to the 1/2, right? If I have x to the 5th to the 1/2, what's my property of exponents say about when I take a power to a power? What do I do to the exponents? You multiply. So what's 5 times 1/2? 5 halves, right? If we just write it as a fraction, it's just 5 halves. So then we can do this. There's a rule we can develop here. Whatever the power is inside the radical, that's the numerator, right? And whatever the index is, the number that you write on the radical, we call it the index of the radical, that's the denominator. So this is x to the 5 halves. Now if I write that in 2 parts, if I write that as a mixed number, what am I going to get? I get x to the, what is 5 halves as a mixed number?
2 and 1.
2 and 1/2, because 5 divides into 2 2 times evenly with 1 left over, right? So 2.5. So all I have to do then is whichever part, whatever the whole number part of the mixed number is, that's going to go outside. Whoops. And whatever the fraction part of the mixed number is, that's the part that's stuck inside the radical. So inside I'm just going to get an x to the 1, and there's the half part, right? It's the square root that gives me the half, so this is going to be the numerator. This corresponds to the numerator of the fraction, right? So we end up with 2x squared times the square root of 5x. Yes?
And didn't you think about it like, if you were to take x to the 5th and like, put it in where it's just x times x 5 times, and then like take out pairs?
You can, right, you can do that. Now, that's going to work. I think this is going to be an easier way to do some problems, because what if you end up with really big numbers in there? Well, what if we had the square root of x to the 37? Right, then you don't want to write out x times x times x 37 times. You could just write it as 37 halves, which is, what's that going to be? 18.5? Right? So you get x to the 18th outside and then x to the 1 inside. See what I'm saying? Okay? So if we write this, in Moodle we'd want to write this as, we don't write the 2, correct? For a square root we get lazy. They're so common that we don't put the 2 there. And we wouldn't put that 1 there over the x. So we would just write it as 2x squared times the square root of 5x. Okay, try another one. How about something like that? So we'll just break it into an outside part and an inside part for the radical. So 32, if we break 32 down using a factor tree, what do we get?
8 and 4.
8 and 4. And what's the 4 break into? 2 and 2, good. 8 breaks into,
4 and 2.
and then the 4 breaks into a 2 and a 2. So we end up with a couple of 2's, another couple of 2's, and a single 2. So that's going to give us, outside we're going to get 2 times 2 is 4, right? Get 2 couples of 2. So I get a 4 out, and I get a 2 in. So square root of 32 becomes 4 radical 2, right? 4 times the square root of 2. Now what about the exponent part? I've got my imaginary 2 right there. So what is the square root of x to the 13? That's same as x to what power? 13 halves. And what's 13 halves as a mixed number? X to the 6 and 1/2, right? So then I'm just going to get, outside I'm going to get an x to the 6. Inside I'm going to get an x to the 1. So in Moodle we wouldn't write that 1, we would just write this as 4x to the 6th times the square root of 2x. Right? That's simplified. Okay? Make sense? Okay? What if we add some more variables? It looks hard, but it's not. It doesn't make it any harder at all. So we just take them one at a time. Well, what about the square root of 4? What's that in simplified form? Just a 2, good. So we get a 2 out, no number inside because 4 is a perfect square, right? What about the x to the 5th? So we get x to the 5 halves. What's x to the 5 halves as a mixed number? Okay, so I get my x to the 2 and 1/2, right? Get it? What about the y? That's y to the 2 halves. What's y to the 2 halves? 1. There is no fraction part. So I just get a plain old y to the 1 with nothing inside. And then z, square root of z to the 4th would be z to the second 4/2, which would be 2 and no fractions. So I just get a z squared out front, and if I write this in simplified form, it would just be 2x squared yz squared times the square root of x.
You don't need this root?
No, you wouldn't. No, you don't. For a square root, you don't put the 2 there. It's just implied. Okay, just like we don't put a 1 in front of the or as my exponent. Okay. Okay, try that one. Everybody, give that a try. Get your notebooks out if you don't have them out. Give that a try.
No advisory for this, right?
No advisory. Okay, let's take a look. Let's see. Dominic, what's if I factor 27 using a factor tree? Give me 2 factors of 27. 9 and 3. Okay, and then the 9 becomes 3 and 3. Okay, so we get a couple of 3s and a single 3. Right? So we get 1 3 out and 1 3 in. Okay? Sean, how about the square root of x to the 4th? That's the same as x to what power? Squared. Good, because it'd be 4 over 2, which is just x squared. So we get x squared outside and nothing in, right? How about the y to the 5th? JJ, what are we going to get for the square root of y to the 5th?
It'll be 2 5/2, which is y squared outside of y.
Good. Y to the 2 and 1/2, so I get a y squared out, the y to the 1 in, and then z would be the same thing, right? We get a z to the 5th. So for the z's, we would get z to the 2 and 1/2, right? So in Moodle, or not just in Moodle, when you're entering this in simplified form, how are we going to, Lauren, how are we going to write that? Well, how would I write that in simplified form? So 3,
y squared,
Z squared.
Lauren,
and inside the square root, 3yz.
there you go. Perfect. Okay,
Oh.
okay, questions? Okay, how about that? Okay, what about cube roots? Now I'm going to show you, this is an easy extension. Easy extension. So what if we want to just deal with the number part, because that's the hardest part. The variable part when you're doing cube roots is no harder at all. It's exactly the same, but the number part is a little trickier. Now when we're factoring square roots, our saying is couples go out and singles stay in. What do you think it's going to be for cube roots? What's going to go out this time? Not singles.
No, it's a
Triples. Triples are going to go out and everybody else stays in, right? Singles and doubles, right? So if we take something like 343, let's have a look at this. If we do 343, we just have to factor this. Okay, well 343, let's see, that's going to be, gosh, what is that going to be? I think that's supposed to be 243, not 343. I think I messed that up. Oh,
Oh, it's on a race.
it is on a race. Oh, it's a picture. That's what I meant. Yeah. There we go. Okay, so 243. So what's a factor of 243? It's odd, so 2 doesn't go into it.
9 and 27.
How come? You're right.
It adds to 3.
Okay, because it adds 2 plus 4 plus 3 is 9, which is divisible by 3. So we know 3 goes into it, and it's going to be 81 times. Okay, what is 3, or was 81 break down into? 9 and 9, and each 9 breaks up into... Okay, so look what we get here then. We get a triple of 3's, and then left over we get a 3 and a 3, right? So now our new rule for cube roots is going to be triples go out, everybody else stays in, right? Well, what would it be for if I was taking a 4th root? Yeah, 4s would go out, whatever you want to call that, quads go out, and then everybody else stays in, right? So on this one then, this is going to give us, if we write this as a part that's outside and a part that's inside, we're going to get 3 outside, and inside we get 3 times 3 is 9. Okay, make sense?
Yeah.
Okay? So let's try one of those with variables. How about this? So we got outside part and inside part. Okay, let's deal with the number. What about 64? What does that break up into? So 2 and 32. 32 is 2 and 16. 16 is 2 and 8. 8 is, and 4 is,
2 and 2.
so we're looking for triples, right? So we get a triple 2 and another triple 2 and nothing else. So what's going to go outside then? 4. 2 times 2, right? Right, that's true, but the cube root of 8 is 2, in other words. So we're going to multiply whatever we get a triple of, that's going to be something that goes out, right? So outside, we're just going to get 2 times 2. Inside, we get nothing. The rest of it is easy. What is, if I write the cube root of x to the 8th with a fractional exponent, what's that going to be? X to the 8 thirds, right? That's got to go on the bottom, doesn't it? So as a mixed number, what's 8 thirds?
Oh, too big for the door.
Got it?
I got it.
What's 8 thirds as a mixed number? 2 and 2 thirds. Okay. So I'm going to get x to the 2 and 2 thirds, right? Okay, how about y to the 7th? What's the cube root of y to the 7th? That's y to the 7 thirds, which is the same as y to the what as a mixed number? 2 and 1 third, right? And then finally, it's the same thing, isn't it? Z to the 7 thirds.
It's supposed to be like, Mr. White has a purple one, but
What's it supposed to be?
inside.
Oh, yeah, you're right. And then here I'm going to get Z to the 2 and 1 third. So if I want to write that in simplified form, I would just get, what, 2 times 2 is 4, x squared, y squared, z squared, times the cube root of x squared, y, z. Would you agree?
Yeah. So now you need the 3 down
Yeah, now you do, because it's not a square root. So otherwise, how would you know what kind of root it was?
there? Yeah.
Okay, the square root's the only one that we don't write the number for, because it's so common. The rest of them, we have to know what kind of radical we're dealing with, right? Okay, last one. Questions on that first?
Wait, never mind.
Okay. Last one. So let's take the number 16. Factor tree, what do we get?
2, 8.
2 and 8. 8 is,
2, 2.
okay, so we get a triple, whoops.
Triple.
Okay, we get a triple 2 and a single 2. So we're going to get a 2 out and a 2 in, right? Okay, Kinsey, what about the x's? If I'm getting an x to the 5th inside my radical, that's the same as x to what power? Say it again? Well, I got a 5 inside. That's going to be the denominator, right? 5 over 3. Okay, good. And if I write that as mixed number, I get what? X to the 1 and 2/3. Okay, good. So that means x to the 1 outside, x to the 2/3 inside, right? Okay, Uliana, how about if I do my cube root of y to the 4th? That's y to what power? Good. 4/3, which is the same as a mixed number as y to the 1 and 1/3, right?
Yeah.
Okay, so that's going to give me a y to the 1 outside and a y to the 1 inside. Oh, gotcha.
We can play catch.
I know what that's for. Thanks.
We can play catch.
And last one, we get a cube root of z to the 8th. What's that going to be, everybody? Okay, good. 8/3, which is going to be z to the 2 and 2/3. So we get a z squared outside and a z to the 2/3. So a z squared inside, right? Final answer. I heard it. 2x squared y z squared. There it is. Right? We good? Go to town. Work on it. Practice real quick so you don't forget. How many? 2? Oh,
I didn't know.
That's not enough for you.
you're right.